Thank you very much. Pleased to be here. As you heard, I've been involved with V6 pretty much since the beginning. Currently, what we're working on is developing test solutions to help people bring IPv6 to their networks in a more expeditious fashion. You may not have heard of our company. Name is Mu Dynamics, and we've been in business for over 5 years now. We've primarily been selling to service providers and network equipment manufacturers and government agencies. And the thing that really differentiates us is that our approach to testing is actually based on real traffic from real networks. It's not really based on RFCs per se. We're not here to tell you what the right way to do something is. We're here to help you take what you already have that works and migrate it forward. And that migration could involve a lot of different dimensions, one of which is IPv4 to IPv6. So briefly, there's pretty much 5 different dimensions of challenges here. There's like migration, there's regression, like in an ongoing basis, people have to actually know. Testing, I should take a sidebar. Testing is actually it gets very complicated very quickly, but it's really about a really fundamentally simple question. When you're talking about functional testing, you're really trying to answer one question: does it work? Like, does it do what it's supposed to do? And regression testing is sort of the future version of that question, which is, does it still work? And interoperability is, does it work with something else? So you're always starting from a place where you hope you understand something works, and you want to actually build on that knowledge and actually leverage it in different environments. And then on top of that, with security testing, you're saying, hey, we're building a new network, it's IPv6. We have this whole 20 years of experience with IPv4 with all these different attacks. I think everyone's probably familiar with all the worms and phishing and other kinds of attacks that come in over V4 networks in the web. You've built all this defense in depth to help protect yourself from those attacks. A reasonable question is, does that work with IPv6? Scale testing is, okay, it works for one thing. Does it support 1,000 or 10,000 or 1,000,000? And then finally, certification is very important, especially when something is brand new. Does it follow industry-accepted best practices? If NIST has an outline of all these different tests that a firewall is supposed to pass, you would like to know that your firewall, in fact, passes those tests. Even if you bought that firewall 5 years ago, you may have new software that you've installed on it. You want to know if it passes the test. So how many people in the room are IT managers? I heard one of my colleagues was here yesterday. He said it was a very technical audience. So just to give me a sense, a few people. So there's a definite sense of hands-on knowledge of networking. Basically, what we have is a unified approach to testing, and I could put a big IPv6 stamp on this whole thing so that you wouldn't be able to read anything else. I mean, ever since the beginning of our company, we've had IPv6 treated co-equally with IPv4. So customers can create content on our platform. The community can create content, and we have a 5,000 user. It's not as big as gogoNET, but we have a 5,000 user community of people who are sharing packet captures, who are actually turning those packet captures into tests. And then Mu, of course, we develop tests on our own. I'll be talking a little bit later about something that's IPv6 specific in that case, but we've developed a lot of protocol implementations for the purposes of fuzzing, and we provide a published vulnerability feed for you so that you can understand if your device blocks things when they come in over IPv6, that your devices did block when they came in over IPv4. The key to the whole thing is automation and making these tests run so that it's something you can operationalize. Today you run it, and then tomorrow you want to just push one button and have it run the same test again. And the purpose of all this testing is scale. So does my test environment support tens of thousands of users or even hundreds, whatever you need? Functional testing, again, does it work? And interoperability, does it work with X? Resilience is, can it handle the unexpected? If I send a packet that, it's an IPv6 packet, but it's not built quite right, something's wrong with it, that packet causes heartburn for my device. I want to know about that before I roll out this into production. And resilience and security are kind of related. Security is intentionally trying to find weaknesses in a system. So to this slide, sort of the parallel to the one before, when you're actually in the process of an IPv6 migration, you have a network that already supports IP version 4. You have lots of examples of traffic that uses IPv4 to talk to your various servers. It could be a web application, it could be DNS, it could be some multicast IP, it could be a FTP, pretty much anything. Voice over IP is a good example of a tricky migration because lots of application developers are sloppy and standards developers. When SIP was invented, that was about the same time period that IPv6 was being invented. And given that people were already in their mind saying dual stack is important, you would think that the developers of SIP would have said no literal IP addresses in to fields or from fields. But unfortunately, that ship has sailed. Those addresses appear all over the place, not just in SIP, but in many applications. So it's not as simple as just flipping the transport and below to go from v4 to v6. Because you're changing the plumbing, but unfortunately, when you take a v6 address, you can't represent it in the same field as a v4 address and expect things to work. It's going to break things. So the conversion process involves a lot of steps that you hope wouldn't be manual. Running a v6 test, what you don't want is to have it take twice as much time as a v4 only test. Interoperability is much more difficult with v6. The primary reason is there's so many different ways to run and deploy IPv6. And the fact is there are a lot of different ways to deploy IPv4 as well. It's just we've gotten used to them all. When IPv4 first came out, it was an environment where there was lots of protocols. You had IPX, AppleTalk, XNS, all these protocols. It was normal back then to have tons of protocols in your network. IPv4 basically took all that complexity and got rid of it. And when v4 was out there, everyone was learning it. All these other protocols, Novell, IPX, AppleTalk, had auto discovery, auto numbering, what IPv6 calls stateless address auto configuration. All these protocols had that. Whereas IPv4, that was back before DHCP. There was no such thing as stateless address auto configuration. And how people were used to the fact that each protocol behaved differently. Today with v6, you got to be concerned about tunneling. You got to be concerned about different implementations. Maybe some implementations still use routing header 0 and other ones don't. There's a lot of differences because everything's relatively immature. So interoperability is a big challenge. Security and resilience. Whenever something is either rapidly changing or new, there should be a red flag for, oh my God, there's probably a lot of bugs in that code. It's not battle tested. It hasn't been widely deployed. I need to be really thorough about sending a lot of unexpected inputs to that code to make sure it's safe for me to deploy. Scale testing, once you've gone through those first initial, does it work? Is it secure? Is it resilient? Those tests are basically one at a time. Scale testing, then you actually say, okay, I've got stuff that works in v4. My network has 5,000 users. It works for v4 at that scale. Does it also work for v6? And then finally, basically across all these different dimensions, certification is very important. You're not only interested in does it work, but you're also interested in does it work according to the industry best practices. And what we have made available, I said that some of our content is actually provided by third parties. University of New Hampshire has implemented the USGV6 network protection device test suite on our platform. So you can actually, through us, get access to this content and run those tests against your existing firewalls, your existing IPS. It's a great opportunity for you to find out, does my device block things as well when I'm running v6 mode as it does when I'm running in v4? I think that the whole point is really to take as much of your IPv4 knowledge and bring it forward without you having to be so concerned about the minutiae of IPv6 as far as your applications are concerned. So I'm pretty sure that this is way too high and way too far away to be able to read, but what I'm showing here is that we have a web application that actually shows you what your PCAP looks like. The center of this slide is a call graph. And what I had done here is brought in a SIP packet capture. And the SIP is running over UDP, and that's what's highlighted on the left-hand side. And UDP in our system is what we call a transport. I mean, it's not a surprise. But the transport has attributes, like what is the source port? What is the destination port? In fact, the other thing it has is a drop-down menu. What IP would you like to run this over? So do you want to run it over v4, what it was when you captured the packet? Or would you like to regenerate the same exact sequence of messages over IPv6? It's just as easy as selecting that drop-down menu and switching it. Now, as I said before, SIP has, at the application layer, it's a string-based protocol. It has representations of an IPv4 address. What are you going to do to make sure that the v6 addresses are also represented up there? Well, we actually put in, automatically, we find the IPv4 addresses that appear in the application. And we replace them with 127.0.0.1 just for display here only. That's not what's going to go out on the wire. This is a transport agnostic representation of the steps in the packets. When you select v6, it changes to : : 1, which is how you say loopback in IPv6. And : : 1 is just another placeholder, which it's eventually going to be replaced by a string literal IPv6 address, which is a square bracket, and then an IPv6 address and another square bracket. And those are inherited from your test bed. So your test bed is where you have all the host information. So if you have one target server, that can have one attribute, which is a v4 address, and another one, which is a v6 address, same device. That's what makes it easy to switch between them. And then at runtime, we will actually insert the correct address into the flow of the packets. Does that make sense? I mean, we're going to actually dynamically regenerate that PCAP, but it's going to be a live session. Now, I've moved ahead to this slide about interoperability testing, and this is just meant to capture the scope of this challenge, which is you're wanting to roll out a new version of something into your network. You have a whole bunch of test assets that you've already had in the past that for various SIP proxies or session border controllers or clients like a user agent client or a server, a phone. Every one of these different devices has different versions, and you've captured the traffic for a particular set of exchanges that worked for this version and that version, and there's a lot of combinations that you need to worry about. Now the question is, you've got a new version you want to deploy. How do you know it works with your existing stuff? Well, you don't necessarily have the ability to go back to the 2.x version of some server. You want to just basically use the traffic you've already got and have our test solution actually play the role of that server and tell you, would your new device be interoperable with something that's legacy that's still in your network? If you want to move your whole test architecture forward to IPv6, all those test assets that you already collected are already able to run in an IPv6 context, even though you originally developed them in IPv4. So is that making sense? I mean, basically, again, back to my original thing about what sets us apart in terms of test equipment is we're not RFC based. We're based on real traffic from real networks. It's your traffic that becomes the test asset. So essentially, if you want to boil it down, what you're doing is actually teaching us how to test your network, as opposed to us coming in and telling you how your network should work. There is value in the conformance tests. We do that too. But when you're doing interoperability testing, it's much more important that we know about all the unique implementations that are floating around in your network. So the way we actually interact with your network is either as a client or a combination of a client and a server. We can have multiple interfaces attached to the network, and We can be running IPv4 on one interface and IPv6 on another to represent the actual interactions that are going on. And we can be testing not just one protocol at a time, but many. And when we're doing resilience testing, the whole point of this is to actually intentionally do bad things. So if a field is supposed to have, let's say, an 8-bit field, and it's supposed to have values up to, 11, a good question to ask would be, what if you set that field to have 255? Or what if you set it to have 0 or 12? All these code paths that handle errors inside of these devices they're the hardest part of the code to test. So we're intentionally going to automatically generate lots of violations that are statefully interacting with the target so that we see if the target can understand when things go wrong. With v6, it's really, because everything is so new, and because all the people implementing this have different levels of experience, what we can do is bring this whole library of things that we know have gone wrong in real protocol implementations from the last 30 years. We can bring all that knowledge to the IPv6 world, so immediately you're going to be getting this library of attacks, if you will, in an IPv6 context. So when we're in the new studio environment where we're actually taking packet captures, we actually can generate fuzz test cases for your packet capture just as same as if we had implemented the protocol from scratch. And I did a Polycom SIP phone, and I generated variants here. I think I got 8,348 variants just within a couple of seconds. So those are all executed statefully. They're all running over IPv6, and they're all going to be showing you the particular faults and the particular kinds of implementation weaknesses there are. You want to find these things definitely before you roll things out. The other aspect of security testing is known attacks. So the resilience testing is really about unknown attacks. You want to be proactive. Security testing with known attacks is things that never should happen, right? You're running a network and there are, say, 30,000 viruses you know about, and your antivirus solution is supposed to detect all of those viruses. There's probably way more than that. And in the intrusion prevention system that you've got, there may be thousands of attacks, but really you only care about the, say, several hundred that matter to you, the way your network is deployed. You need to be able to run the known attacks across your network, and you don't care, is it v4, is it v6? You just want to run them across your infrastructure to test your defense in depth. Does that actually handle the attacks regardless of whether they come in over IPv4 or IPv6? We've done tests with our partners, UNH, ICSA labs, and other labs. We have done tests against real firewalls, real IPSs, where they will just say you send 100 attacks, and nobody's perfect. Let's say 80 attacks get detected over IPv4. Run the same 100 attacks over IPv6, you'll be lucky if you get 10 to be detected. And again, at the TCP layer and above, it's the same. So it's really important not to make any assumptions about what the network equipment is going to do until you test it. Finally, what we have is the ability to turn those packet captures from your network into a scale test. So if it's a SIP call, you have Alice calling Bob. Alice is, say, the from field, and Bob is the to field. You can turn both of those fields into options, and then we can automatically generate for you thousands of names. So Alice's friends are calling Bob's friends, and they're all talking using the same conversation steps. We then run thousands of these concurrently, and we can tell you if your network can handle a mix of v4 and v6, or tens of thousands of v6 concurrencies, and show you how much throughput that is, how many tests are passing per second, how many are failing per second, and what the overall delay is for each one of the calls. We also keep track of the call flow diagram, how much delay and other passing, failing, timing out is associated with each one of the steps in the call flow diagram. So if there's a part of your network, SIP is very dependent on DNS. Almost every SIP message requires multiple DNS lookups. If one of the steps in your scenario is DNS lookup, and if your DNS is running slow, that will affect the ability to complete lots of SIP calls. So we will actually show you the DNS step here, and we'll show you, hey, that call, or that part of the call flow diagram is taking 100 times as long as all the other steps. So you'll be able to, at a glance, notice, oh, okay, it's actually the DNS server that's slow, and I need to upgrade that to make my voice over IP performance be better. So I alluded to the third-party content earlier. Our platform doesn't just do test execution, it's also for test development. And NIST has defined the US government IPv6 program, and I'm sure you're all familiar with the IPv6 forum and IPv6 Ready. The IPv6 Ready program for hosts and routers is sort of grandfathered in to USGV6. But there's a whole big class of important devices, which are NPDs, Network Protection Devices. And NIST, no one else had ever done this before. NIST defined about 27 to 30 categories of tests for conformance and interoperability of firewalls, intrusion prevention, intrusion detection, application firewalls. They actually built all these tests, and they built them in a document that was written in English and very easy for people to read and understand, but it's not something that you can automate. UNH is one of the approved test labs for this program. And how many people have heard of the University of New Hampshire's Interoperability Lab? Yeah, they've done a lot of work in this space. They actually came to us and said, we need help. The number of firewalls that are on the market is in the thousands. And the federal government is buying $65 billion, non-defense, $1 billion every year in IT. And the USGV6 program basically says that starting July 1st of this year, if you want to purchase equipment, it has to have, the purchase order or purchase request has to have a supplier's declaration of conformity. And that means you have to be able to attest to what degree your device supports IPv6 if you're in the federal government and you want to purchase IT equipment. So the NPD tests are how to test a firewall. And they developed this in our platform because they needed the automation. ICSA Labs came out with a shocking statistic February of this year actually. They've been in business for over 20 years. They said, let's look back. They've been testing firewalls. They're like, let's look back over the entire history of our business. And we're only dealing, we're not dealing with like, Bob's sub shop. We're dealing with companies that are building firewalls. They understand security, right? How many times in the 20-year history of our company where we've focused entirely on testing firewalls, how many times has a device passed on the first try? How many people want to guess the answer? It's not 0. You're way too pessimistic. It was 4% of the time devices passed on the first try. Now, the way these companies work and do their testing is you only pay once. So if you give ICSA Labs $20,000 to test and certify your firewall, if you have to come back 7 times, that's bad for ICSA. It's bad for UNH. They can't afford that. And at the rate at which things pass on the first try, that's a guarantee that it's going to, they're looking at this USGV6 program. Every firewall that's currently on the market has to be retested for IPv6. Okay, the amount of work that would be required is insane. And especially, it's doubly insane if something has to come back twice. And you're going to the back of the line. If you fail, there's more work for them to do like right now that they can't just retest you right away. So they needed automation. And both ICSA Labs and UNH came to us with the same requirement at the same time. It said, help us do this testing in an automated way because we are just doomed if we're going to try to do this manually. And so after we've had this success, we've had this content available for a while for NPD testing, people started asking us for more. UNH developed the content for NPD testing. ICSA is also developing content for NPD testing, but everyone's asking us for IPv6 ready. And that's a much bigger scope. The NPD testing is only about, in category terms, a couple dozen different categories. It amounts to tens of thousands of test cases, but it's only a couple dozen categories. IPv6 ready, you're talking about 500 categories. It's quite a bit more involved. But we heard people asking for it. They're like, help us. We can't do this quantity of testing ourselves. We have a lot of equipment that we have in our networks today. How are we supposed to actually know if it's good or not? A lot of this stuff hasn't been tested. You know, I mean, there's been a bunch of devices that have been certified by IPv6 Forum, and they have the logo, but there's a lot more devices that haven't. People still want to know if it's following the rules for the conformance and interoperability, base level conformance and interoperability around IPv6. So we just actually announced this week to our internally that this content is now available for free. I mean, we're giving this away. It's part, it runs on our platform, but it's just one of the many kinds of content that's available for IPv6. In the future, what we've got now with IPv6 Ready is Phase 1 and Phase 2 core. Phase 2 core plus Phase 1 is, like I said, about 500 test cases. There are many other modules inside of Phase 2 testing. There's NEMO, there is IPsec, there is MLDV2 for multicast, which is like IGMP for IPv4. There's just many, many modules, and those are going to be coming out over the next few months, 3 to 6 months. We'll have all of them by then. And Phase 3 is coming too, which I'm not privy to the process, but what I hear from my contacts is that Phase 3 is going to be much the same as Phase 2. The only real difference is that, and I think mostly from NIST's encouragement, Phase 3 is going to mandate IPsec. And IPsec has been around for a long time. And it's certainly available for IPv4. But the government is actually trying to encourage IPv6 vendors to, I mean, you know, they're the customer. What they want, right or wrong, that's what they want to buy. And NIST really wants IPv6 to live up to one of its benefits. The number one benefit of IPv6, bigger addresses. The other thing people have been writing about, every article in every trade rag for the last 10 years, allegedly IPv6 magically has better security. I'm not sure how people come to that conclusion unless people actually insist that IPsec is actually part of your IPv6 implementation. The standard says it has to be there, but the IETF doesn't have like a military arm associated with it that's going to go out and force people to do things the way the standards say. And if no one asks for it, no one will do it. So the pressure really from the market has not been there for IPsec. But now the government is actually asking for it. And the IPv6 Ready logo program is going to be, you know, as they move forward to Phase 3, they're saying we're going to actually mandate IPsec, just the way the standard says. They also have some SIP-specific logo program now around IPv6. You might reasonably ask why it's important to test SIP with IPv6, but as I showed, there's a lot of IP addresses that appear in the application layer. There's a lot of different ways that proxies have to handle these things, and SIP is very important for voice over IP, which is just now starting to take off at the same time that the IPv6 transition is happening. There is an awful lot of likelihood that SIP is going to need to run over IPv6 and to work cleanly. So that's why they're very interested in that. And finally, the DoD is, you know, as I said before, NIST standard for USGV6 affects non-DoD. DoD has their own set of standards around IPv6 compliance, conformance, interoperability. And so they're actually running this stuff as well to you know, a lot of this stuff feels similar. You know, there's only one way to do things right. There's a lot of ways to do it wrong. So if somebody has an IPv6 forum test that shows how to do a particular feature, stateless address auto configuration, et cetera, you're going to see similar test cases in the DoD standard. But you have to follow their specific set of requirements to actually accomplish the test. So what does the NPD content look like? Basically, what we do is we equate a single scenario. So we might have a single packet that is a UDP over IPv6 packet. And we expose a lot of knobs. So all the fields, like the traffic class field and the, you know, the hop limit and all, you know, the next header and all the, you know, there might be a routing header in it. All these headers are exposed and all the fields are set up as options so that we can then go into a test set and say, okay, we want to actually set the field for this ICMP error message to be packet too big. There's a code value for that. Or we want to set it to time exceeded or parameter problem. I mean, and then we can also do a test where we say, you know, I don't want to do this single one-off kind of a test. I want to just do a range. That field can go from 0 to 255. Just work your way through all of them. Tell me which ones work, which ones don't. I was testing a firewall. I can't tell you who. But they passed all the tests when they were the one-off tests. So it was supposed to block certain ICMP types and codes and allow other ones. The NPD spec says that between certain private and public addresses, you have to block and allow certain types and codes. And all of them worked at the level of granularity of this type, this code, blocked, yes. This one allowed, yes. They all worked that way. But then I said to the UNH folks, like, I wonder if we should maybe just try them all to see what happens. And he's like, wouldn't that take a long time? I was like, no, no, no. You just use this range command. You go start for 0 to go to 255, you're done. And one of the tests involved a range that was up to 16,000, and it was the end of the day. So we just started the test, and we came back in the morning. Half the tests failed. As soon as the type got to 128, somehow all the tests started to pass. And these are, you know, this is supposed to be a firewall that blocks things by default. So the things that were allowed were all less than or equal to 127, and they were very specific. Things that were supposed to get through, supposed to get blocked, all those tests passed. But as soon as the value got above 128, so the high bit was set in that field, all the tests, all those packets got through. And the vendor was at a loss to explain why that was happening. But I mean, the ease of generating the test was what made it possible to actually find that out, which they would never have known otherwise. Because there's hardly any types and codes like that are actually with V6. Most of them are above 128, but the undefined ones start about like 134 or something, and then go beyond that. So it's there's a lot of opportunity to find things just by checking everything. As I said, all the USGV6 testing that UNH is doing is being done with our product, but it's their content. And it is available to anybody for free right now. People not only can do the NPD tests, which is certainly very valuable if you're a firewall manufacturer, but they can also just use these templates as an example. How do I start with IPv6 testing? Well, how do I build a v6 packet? Maybe I need to do some testing that's at the Ethernet layer. How do I build myself a complete IPv6 packet? Or maybe I need to do some TCP layer testing and I just want to run over IPv6. This test suite gives you a huge set of pre-written examples that you can edit and hack to your own satisfaction. And you can also, in your own lab, replicate what UNH does in their lab. So they would love you to actually have done the testing before you arrive at their office. Because, as I said before, you only pay once, and they would like you to only visit them once. They want you to pass on the first try. So to summarize, we've been building test equipment for 5 years now, and all through the history of our company, IPv6 is in our DNA. I mean, we've been doing this from the beginning. All of our ground-up protocol fuzzing, our published vulnerabilities, like every feature that we have if there's a way to do IPv6 with that protocol, we do it. And across functional testing, migrating from v4 to v6, interoperability, v4 or v6, security testing and resiliency, scalability, can my network handle 1 million users? I mean, when we introduced our scale testing feature, immediately people started saying, I need to actually run a web application in the cloud and have like 1 million iPhones or Android phones connecting to my application. Can you help with that? It's like, yes, absolutely. And then certification. In this market, in v6, certification is huge. Everyone needs to be certified, and a lot of people have legacy equipment. How many people probably have equipment that still supports routing header 0 and doesn't know the equipment was written long before that was supposed to have been taken out of the spec? Or site local addresses, like those are now deprecated as well. I mean, like you have link local and global today, basically, and a multicast. There's a lot of fluidity in the standards, and you want your test equipment to be as fluid and be able to change as soon as you need it to. We're able to basically get you up and running and testing for IPv6 certification, like within 15 minutes of taking the box out when it arrives. And not only can you do testing immediately, but you can actually take that as a jumping off point and actually start building your own customized tests. And we're leveraging industry best practices because the industry is actually developing the test content using our platform. So hope that's been informative, and I think I actually did it in a half hour, which is, yeah, I'd love to take some questions if anyone has any. Yeah. We're actually a member of the PCI consortium, and yeah, I mean, I know that PCI has kind of a bad track record. I mean, back in the day, you could get a PCI auditor to certify that you had a firewall if it was still shrink wrapped on a shelf in the back and it wasn't even connected to your network. It's like they come in and say, hey, you've got a firewall, check. Yeah, so a lot of the requirements are maybe nonsensical. So what we try to do is actually help people turn these requirements into real tests that interact with real devices. And if you can't make a requirement interact with reality, it actually helps push back on some of those things. I would love to talk about specifics, but I mean, like, we're at this point, we're more focused on some of the layer 3, layer 4 type things that are a little bit distinct from, say, more of an application like PCI. But I'm not averse to, you know, speaking up. Oh, yeah. So many of the conformance tests that we have actually are based on RFCs in that. So UNH was actually developing content that NIST said you need to basically send a packet that looks like an IPv6 packet with routing header 0. So we actually sat down. We had one computer over here with the RFC open in one window and looking at the packet header structures. And in the other window, I'm actually typing commands on our appliance to actually say, okay, there's a new field, it's going to have 16 bits and it needs to have a default value of 0, and then the next field is like 32 bits and it needs to have a default value of whatever. And so we built that packet structure following what the RFC said. The purpose was not to actually go through the whole RFC, though, and say, we've now tested the RFC. The purpose was to say, NIST says this packet, and they don't actually tell you the packet format. You have to go look it up. But NIST says this packet should be blocked. And so we need to send a packet that looks like the RFC says it should look. Yes and no. Sometimes they're saying, we want to send a packet that we know is bad. like a packet with routing header 0. Used to be legal, now it isn't. So firewalls are supposed to block it. So in that sense, it goes against the RFC because over time, the RFC has changed. Mm-hmm. Sometimes. Yeah, and then they can develop a test case that says, we want to see if this feature actually works. So, I would say that most of what NIST is actually defining as far as a test case goes is things that we've known about since 1996. Stuff that hasn't, they're not really trying to actively stay right up on the bleeding edge with their testing. They're basically saying stuff that should be stable, stuff that's supposed to work, does it work? And so here's the standards to follow. And the same thing with IPv6 Ready. If you look at the list of standards, you've got like neighbor discovery, you've got like ICMPv6, IPv6. There's maybe a handful, literally a handful of standards that they're testing against. There are way more than, there's probably, if you count all the hands in this room, there's enough standards to be filling up all those hands today around IPv6. And no one's really testing all of those to that level of conformance. But if you have a use case where you actually need to develop a test that matches up with a standard that literally is still an internet draft and hasn't even been published yet, well, there's no reason why you can't actually build a test for that like today. It's really easy. When we actually interact with a system, we're actually paying attention to things that come back. You send an ICMP message and it's got a value in this field, and you expect the response to have a different value in that field. Well, the test will fail if it doesn't have the correct value in the response. We're looking at assertion-based testing, not just counting the packets. We're not going to just send 1 million packets and tell you the test passed if 1 million packets got through. We're really paying attention to what the target is saying back to us. Different than what? Ixia. Oh, I guess that was kind of what my last point was. So Ixia is much more oriented toward testing layer 2, layer 3. It's not really very stateful. So, and it's based on only canned content that they define. So if I bought an Ixia test equipment today, and if you bought it, you and I would have totally different reasons for using it, but they're going to ship us the same exact solution. So, and the ease of customization is where we really shine. You can literally build any packet in our system. And you can make it match your network. And you can change the traffic from V4 to V6 and do all these other fancy manipulations. With Ixia, they're really good at sending lots of traffic and counting. I mean, they've special hardware to be able to count lots and lots of packets, tell you the latency and the jitter and other things. When you're testing applications, you more care about, when I sent this sequence of packets, did I get the expected response? How many, if I have millions of people or hundreds of people or however many sending the same kind of transaction against my server, where does it start to not scale accordingly? So Ixia is just fundamentally answering a different question. It's not a bad question, it's still an important question, but like load testing really stops being very relevant when you get above layer 3. The load testing that you do at layer 4 for, say, HTTP servers, you can do that in a stateless way and also in a stateful way. So we try to tend towards saying stateful. Thanks.